Okay, thank you so much, Tanya. And with that, we are going to turn things over to Hannes Walter, Vice President of Product Management, right, from Blackshark.ai. And we're going to be talking about some really exciting things with very large-scale 3D simulation environment generation. Okay, everybody, please help me in welcoming Hannes. Can we get the virtual claps for that?
Thank you so much. Thanks, Tali. Thanks, Tanya, for the invitation. I'm very honored to being able to showcase and explain and demo what we can do with our technology. The next event sounds very interesting to me as well, so I definitely need to sign up for that and so that I don't miss that. That's a perfect topic for me. Yeah, and at Blackshark, we do very large scale 3D simulation environment generation, not only based on satellite imagery, but for global scale, no other data set is available than satellite data. So this will be the main focus of my today's talk. Feel free to drop some questions. Quick intro. I'm based here in Austria, in Graz, where Blackshark is headquartered as well. I'm leading our 3D simulation environments team, providing this large-scale simulation terrains. Our background is the Microsoft Flight Simulator, so we are a spun-off of a video gaming company called Blackshark, called Bonkfish, which is also located here in Graz, Austria. This company did procedural terrain generation for the last 20 years. The first game was a snowboard game on Mount Fuji and other mountains. And so we had always a focus, the emphasis on procedural large-scale terrain generation, but of course, based on Microsoft Flight Simulator, entire globe. We put this into another and next level. Based on all this work the team did, the Microsoft Flight Sim team reached out to us about 8 years ago and asked if we can provide the entire globe in simulation ready, awesome looking, streamable 3D. And of course, the team took on the challenge. And it was pretty clear from the beginning on that there's no other way than machine learning and AI to solve this problem. So our team built an entire new AI-based platform to make this happen. And after the launch of the Microsoft Flight Sim and the big splash, it was clear that we need to provide this technology and capabilities to other industries and communities as well. Based on this, we got a very good initial funding, 0.72, Microsoft, Maxar, InQtel, and others are core investors currently. So we secured our Series A funding round mid of last year. And here we go. Our deck, in a nutshell, we take not only satellite imagery, but all kinds of sensor data and train machine learning models to extract necessary features out of it. So this is so far so good and pretty common. Meanwhile, back then it was completely unique. And then we do another magic step and we synthesize the entire globe or large scale areas based on these attributes which we extract from the satellite imagery. Quick preview on what we do. And now in more detail, I want to give you an overview of our geospatial intelligence capabilities because, we had been a pretty small team for the entire project and we had to be very creative and basically come up with our own tools so that we can train global ML models ourselves. And we launched this tool end of last year for everyone. I'm gonna pause here. What you see is our tool, which runs on AWS on a standard setting, but it can be operated on-prem, air-gapped, and locally as well. And what you see here is that we point satellite imagery to the tool, and on the left-hand side, the user is simply labeling the object of interest. In this case, it's mining trucks. In yellow, and this pinkish color means this is not what I'm looking for. And the tool provides you instant feedback on the right-hand side and the right-hand screen of what the model understands so far. And within minutes, you have a custom machine learning model trained based on your inputs and based on this tool. And so you can, within minutes, create new training and label areas. So we have here a first area. Now we do a second one. And for the second one, the preview of the model is pretty good already. So we only need to refine and add some more additional labels. And with each new training label, the model gets better, more robust, more accurate. And whenever you are happy with the result, you can then deploy it on very large scale. So we can do global detection runs if necessary. And here you see the detection results then as geo coordinates, as centroids, or we can export the vectors or the raster results. And as you will see a bit later, we're gonna use these results then for the simulation environments as well. So this is one of our secret sources, but as I meant, you can use this as well and get access to this Orca Hunter tool, as we call it. Here's another example for oil field equipment. And as you can see here, it's not just capable of training a single ML model, but you can train up to 8 different classes at the same time. In this case, it's about pump jacks and tanks. And I'm gonna fast forward here a little bit. So we did these 6 training areas, and then we're gonna deploy this and do a large-scale detection run. And we are getting then the results as, again, geo coordinates, which we can then implement and use in the simulation environment. And this not only works with objects, but also with land use, land cover information. I'm gonna fast forward here again. Here it's about detecting trenches in the Ukraine. So yellow is trenches, pink is no trenches, and this can be deployed on any kind of biome, land use, land cover information, or object. As you can see here, so multi-class doesn't only work on satellite imagery, can be deployed on aerial imagery, on drone-borne imagery, in theory on any sensor data. Doesn't need to be optical or visible. Yeah, this is one secret source. And of course, for the Microsoft Flight Sim and for our global scale simulation environments generation, we have pre-trained models as well. So in this case, it's mainly about buildings. So building footprints, building splits, building attributes like building height, building roof types, and so on. So we spent quite some effort into this global building detection model. We have very good pre-trained vegetation extraction models as well. Currently, we train a road network and water body model and so on. So for the most important layers we train the models, but of course, depending on the use case, industry and so on, our customers are interested in all kinds of models, and we don't want to be this data labeling and ML model training company. So we rather provide you the software tool so you can easily train your own custom machine learning models. But all of them are highly scalable. Here we are on the Iberian Peninsula. This is Portugal and Spain here. So the OSM OpenStreetMap data set contains about 5 million buildings here. The Open Microsoft building data set contains bit less than 9 million, and we detected 17 million buildings within this area on a single GPU in less than 5 hours. And our entire platform is fully scalable, so we can fire up hundreds or thousands GPU nodes at the same time. And this allows us to do change detection at large scale as well. Here's one example. After the earthquake in Turkey and Syria, we did a building detection run based on a data set from Maxar from 2021. And we compared that with the data set which was released one day after the earthquake. And based on that, we can easily identify where the buildings were destroyed to, for instance, give some guidance to disaster relief teams, especially to remote areas. Everything I've shown so far was done on satellite imagery, but as I mentioned at the beginning, we have pipelines for aerial imagery as well. So what you see here is Seattle fully automatically extracted based on 7.5 centimeter aerial imagery. Here's another example so that you have the comparison what the reality looks like and what our pipeline extracts from this data. Yeah, there are several interesting use cases around our Orca capabilities and our Orca Hunter tool, of course. For instance, land use, land cover extraction, as I meant already. And we use this then to reconstruct this area in a synthetic manner with a fully automated artificial intelligence-based pipeline. If you have more questions, ping me or my counterpart for our Orca Hunter product line is my dear colleague Gastao. So he's the expert for any specific questions on our Orca capabilities. Now switching to my business line and our core capabilities within our team. So basically we take the results coming from this geospatial intelligence pipeline, plus the terrain data, plus the satellite data and so on. And we generate this simulation-ready 3D environments in a fully automated and highly scalable manner. As you can see here in the background, so this is an area in Italy. Just as a reminder, we can do this with all kinds of input data. We have a base globe derived from Maxar Vivid 50 centimeter satellite imagery, but we can apply the pipeline on any other data as well. Yeah, to provide environments like this. So we have a generative and procedural content generation pipeline in the background, which turns then all the vectors into this photorealistic 3D environments. Yeah, and I'm gonna give you a quick demo based on our Unreal plugin at the end anyway, so we can have a closer look at it. But what we do here is basically taking all kinds of input data. All this data needs to be georeferenced, of course. So satellite aerial, digital elevation model, the building vectors, vegetation cover, airport database. So we have a full-blown airport generator as well, generating very detailed simulation-ready airports, including all the light systems, markings, and so on. Or yeah, we can ingest global scale power line vectors, road networks, and so on. And we feed all this into our Synth3D service. And this service generates then the Synth3D geodatabase. So we have customers who run this service themselves in their environment, or we run it for our customers, and then basically you get the result from us already. So the simulation ready environment. The turnkey solution is derived from MaxaVivid, but for several regions, countries, and so on, there's awesome public data for free available even. So we can work with that as well. Or some of our customers bring their own data, or you can basically choose which area or which layers you want to get from us and spice this up with additional data layers which you're going to provide. So our base map derived from MaxaVivid, where we extract then the building footprints, the building attributes, the building vectors. We use the AstaDem for our base globe. And as I meant, we have a data partner for airports as well. So all this then generates these regions out of the box as a service. Ready for nighttime visualization. Currently, we are working on street lights, so not city maps. So you can really go down to ground level, and we procedurally then place all the lights and so on as well. Here are some examples for airports. This is San Jose Airport, or rather big one, but yeah. We have the biggest airports in our repository already. This is a military airport. This is Aspen Airport. That's a very remote landing strip in Papua New Guinea. And we can embed all this in our global model. So basically we have this vectorized, procedurally generated airport insets. We embed this into the 50 centimeter derived Synth3D terrains, and we can embed this into a low-res globe as well. The reason for this is mostly to save some hard disk space, because it's yeah, the entire globe is about 10 petabytes of data for the satellite data only. So our portion is rather small, but if you want to have the entire globe covered with 50 centimeter satellite data, that's a massive amount of data. So we have several options, either to only provide the core areas with 50 centimeter, or synthesize the entire areas so that we can basically store the entire globe on a single hard disk drive if necessary. Here are some examples. Saudi Arabia, Medina. So we have several projects for customers going on in the Middle East region. This is our hometown, Graz. Again, based on our Unreal plugin, we are fully compatible with very interesting additional Unreal plugins as well. In this case, it's Ultra Dynamic Sky. So we can simulate all kinds of weather situations. And as you can see here, we have weather affected surfaces as well. Some regions in Germany, Salt Lake City, Egypt, just to give you a broad overview. of what our globe looks like. We can provide, or we can, our 3D data not only provide for Unreal, but we can export it in OpenUSD as well, so that it can be used in Omniverse, for instance. Or we have 3D tiles exporter and 3D tiles connector, so that it can be either directly hosted on Cesium or used with the Cesium plugin for Unreal. So in terms of integration, we have all options. Under the hood, there is a C++ SDK, so we have also customers who directly integrate based on our C++ SDK into their render engines. So completely open framework in this regards. Coming from Microsoft Flight Simulator, of course, flight sim and pilot training is still one of our core use cases. We just recently announced the partnership with True Simulation, so they are using our terrain generation capabilities based on Unreal for their new Varis simulator based on head-worn devices. As you can see here, this is a high G-force trainer and some examples of additional examples of airports and helipads. But there are all kinds of other use cases as well. In this case, it's about sustainable forest management. So based on our Orca Hunter tool, we can extract the necessary semantic information from satellite imagery. In this case, of course, it's very interesting to use multispectral data as well to get more information about the type of vegetation and so on. And then we can again ingest this semantic vectorized information to do all kinds of visualization, reconstruction, calculation, simulation, as we have then the semantic information and the metadata to do all kinds of calculation on top of the data. 3D city visualization, another interesting use case. For many countries, there is no 3D data available at all. So it's really a flat Earth in this regard. And here are capabilities to provide a base globe derived from satellite imagery is very interesting. And of course, that we can basically update on a daily basis is a very interesting feature and capability here as well. Again, all the buildings, the entire globe is semantically defined, meaning we can stylize, simulate, depending on various features, so that the user experience is implemented in the best possible manner. Another interesting use case, 3D synthetic training data generation. As we have this photorealistic and simulation-ready 3D environment, meaning we can simulate all kinds of camera angles, weather situations, nighttime situations, and so on. And we can procedurally and automatically place all kinds of objects on top of the semantic data based on rules. We can generate hundreds, thousands, or millions of already labeled training images so that our customers can train their ML models on top of it based on this synthetic training data. And as our entire framework is fully scalable, it's also very interesting to train autonomous systems by all means. So drones, autonomous vehicles on the ground, and so on are trained based on our semantic 3D globe. Another very interesting example, as we can easily simulate a certain flood level and then calculate on which flood level which buildings would be affected, we can automatically visualize, stylize, and yeah, generate a database for flood level simulation, and we can provide the according visualization for this use case as well. We just recently implemented a sensor simulation plugin for Unreal as well. So here you see the realistic visual view for the human eye. Here you see the material attributes which we generated, visualized in different colors, and based on this material information and the georeferenced information, we can then automatically simulate all kinds of sensors based on our globe. Large-scale infrastructure reconstruction visualization. So for the US, there is an open database with all the currently, I think, 65,000 wind turbines in the US, including the geo coordinates. So yeah, we basically implemented all the wind turbines in the US and placed them on our globe in a fully automated manner. If the database contains the information what kind of turbine this is, then we can automatically place the right wind turbine model here as well. And if we have the live IoT data, we can even mimic the spin, the speed, orientation, and so on. So for us, it's really about global scale vectorized simulation environment for all kinds of use cases. Virtual media production. So the Olympic Games are coming up. So watch out for Blackshark in the media. There will be some very well-known media companies using Blackshark for their virtual media production around the Olympic Games. Also another very interesting use case. And now, super quickly, an outlook, what's coming next. So I want to zoom in now from high altitude going further and further down. This is Hawaii, Oahu Island. And with our Orca Hunter tool, we extracted the land use, land cover information. Going down more to the ground level. So land use, land cover information, which we then gonna use to synthesize the entire terrain. So we can either use satellite imagery as ground texture, or we can then procedurally generate and synthesize the terrain. Here, Unreal's PCG capabilities are, of course, a perfect match with our semantic globe. Another example, satellite imagery, and in this case, the generated buildings and vegetation on top, or we synthesize the entire globe, or entire terrain, sorry. Now coming more and more down to ground level, and of course in the end it's about synthesizing and reconstructing also the roads, railways in an as accurate and detailed manner as possible. So imagine if we have fleet-borne imagery taken from the ground and not just 50 centimeter satellite imagery. Of course we can extract road signs, road markings, and all kinds of other things as well, which can then be used for the procedural reconstruction of the ground level. Or another example, if we detect solar panels in a certain area, then we can procedurally and automatically place solar panels in our 3D environment as well. Okay, I'm gonna stop here now. So that was the high-level overview, and hopefully this will raise some questions and we'll kick off a discussion. And while this, I'm gonna fire up a live demo in the background, and then we can have a look on Oahu on the latest version. Yeah. If you have further questions, please drop me an email. I'm gonna start the demo in the background, so happy to take your questions now.
Connie, do you want to go ahead and feed these?
Yeah, so we have one question. We're talking about the building textures. Oh, and you've got a ton. Thanks, Kelly. So the first question that I have recorded right now, it's are the building textures also generated automatically?
Sorry, can you repeat, please?
Are the building textures generated automatically?
Yes, yes. They are synthetically generated though. So in our base globe, we only use author-rectified satellite imagery. So we don't have any information about the building facades. So all the facades you see, or all the buildings, are synthetically generated in a regional typical way, fully automatically. So yeah.
Telly, are these yours? All right.
Yeah,
Going back to
while I was going through
it. For Orca, we're looking at Orca HNTR. Is this trained to look for specific types of objects, for example, trenches and boats, or could you have it search for any like large object?
Basically, it can be used for any kind of object. So it's really about what can be distinct by human brain and human eye can be trained with Orca Hunter. So we have, you can't imagine. So the variety of models which are being trained by our customers are insanely wide. And for us, it's very interesting to see what kind of models are being trained. The models belong to you, by the way, so we don't share the models with other customers and so on. They belong to you. We can set it up in a way so that no one else sees what you are training on and so on. But back to the question, basically, if it can be spotted by human brain and eye, it can be trained with Hunter.
For change detection, how often are the databases updated, and how long are they stored for?
So for change detection, so in this regard, we don't provide data. Basically, if you provide a daily update, you can run the change detection on a daily basis. If you have a data provider providing you with a monthly update, you can basically do a monthly update and change detection based on that.
We also have for Synth3D, how optimized are these large-scale environments for various platforms, and could these deploy to mobile platforms?
So the example I've shown for the Varis, so True Varis is the brand or the name of the simulator, is based on a head-worn device. And for the official regulatories to get so-called level D approval, it needs to run on 90 frames per second on this head-worn device. Just to give you a ballpark number in terms of render efficiency and performance. So it's super performance optimized and really meant for high performance use cases.
We have another question. For roof shapes, will the roof shape also be detected by the AI model?
Yes. So here we are in Oahu, and basically if I go to a building, I can click on the building and query all the metadata available for this building, for instance. Some of this metadata is based on the initial input data. Some of the some of the metadata and attributes are detected. But yeah, the question regarding the building roof type and roof shape, yes, it's extracted as well.
We've got more questions coming in. I like this. For object detection, what are ideal conditions for training AI models? And when are the AI ML, when do they have what do they have a difficult time predicting, or when may they have a difficult time predicting? So for object detection, what are the ideal conditions for training AI model? That's the first question. So, and then we have a follow-up.
This would be a question I would pass on to my colleague Gastao, because he's the expert here. So yeah, happy to pass this on to him. He certainly has the right answer to that, but I'm not the expert for the change detection and geoint aspect here.
We have another set of questions. What is required to develop the high fidelity ground level models and textures of a city for ground level training simulations?
What is necessary? What you see here is basically the biomes, and in this case, I think it's OpenStreetMap road vectors. And we're gonna provide a base version for the ground level reconstruction as well. We have a strong focus on airport areas, as I mentioned already. So here we reconstruct the area in a very high detailed manner. And from there, we're gonna expand this ground level generation capabilities around roads and biomes. But based on the semantic data, you can go wild with BCG basically as well. So this is the good thing. We expose the semantic data, and if our reconstructed base globe is not good enough, then you can go wild based on BCG and yeah, bring it to ultra photorealism if you want or need.
Fascinating. I think that's all of the questions so far. Did not see any others.
Maybe, yeah, I just want to mention that we have an early access program as well. So if you're interested in getting hands on the SDK, on sample data and so on, just shoot me an email and then we can provide you our Unreal plugin, including some sample areas as well, so that you can test, integrate, and provide us feedback as well. All right.
All right, well, awesome. Thank you so much, Hannes. Do we have any last questions from anybody in the chat at all? Going once, going twice. I feel like I should actually give this like more than just 5 seconds, so that way people can type. Guys, do you want to go ahead and just drop your email in the chat for those who'd like to reach out to you and get further information?
Sure, definitely. Yeah.
Wanting to know, is there a demo version from your product which can be downloaded? Which I think you just said, yeah, that's available, right?
Yes,
Yeah.
correct.
Hannes, do we have to email you to get access to that SDK?
Yes, currently, yes.
Okay.
So there is no
Okay,
automated.
thank you.
Okay, I'm going to go ahead and stop the recording, but before I do, everybody help me in giving Hannes a virtual round of applause. Thank you so much for joining us today.
Thank you. Thanks for the invitation. It was a real pleasure. Great questions. I really loved the questions. Cool.
All right, thank you so much.